Welcome student to online classes of mathematics for class 9th. In this video we will cover the exercise 1.3 of chapter number 1 number system of NCERT textbook. And this is our session number 3 for this chapter. Myself Deepak Gautam, TJT Mathematics in Kendriya Vidyalaya Sangathan. So let's start today's session. Here we are discussing chapter number 1 number system. We have already covered introduction part in session number 1 and irrational numbers in session number 2. This is session number 3, which will be based on the real number and their decimal expansion. The real number and their decimal expansion. When you find the decimal expansion of any real number, it will be of two types. One is terminating, second is non-terminating. The non-terminating are again of two types. One is non-terminating recurring. Recurring means repeating. And the second one is non-terminating and non-recurring. That means decimal expansion will not terminate. Also, the digits will not be repeat. Both the terminating one and the non-terminating but recurring are called the rational numbers, while the numbers whose decimal expansion is non-terminating and non-recurring are called irrational number. The one example of non-terminating but recurring is like number 0.6, 6, 6, 6, 6 and so on. Here you can see the decimal expansion is non-terminating, it is going continuous, but it is recurring. That means digits are repeating. And the example of non-terminating and non-recurring can be a decimal expansion. If the decimal expansion of a number is 0.101000100001 and so on. So as you can see, the digits are non-repeating, also non-terminating. Okay, just also written here. The decimal expansion of a rational number is of two types. One is either terminating or non-terminating recurring. Or we can say this in other word, that a number whose decimal expansion is terminating or non-terminating recurring are called rational number, while it should be 2 here. The decimal expansion of irrational number is non-terminating and non-recurring. Non-terminating and non-recurring, or we can say that a number whose decimal expansion is non-terminating and non-recurring is called irrational number. Okay. Now let's start the exercise 1.3. Okay, here we are going to cover the exercise 1.3. We are doing here the real number and their decimal expansion. So we have exercise 1.3, which in total have 9 questions. We'll cover all 9 questions in this video. Question number 1 is write the following in decimal form and say what kind of decimal expansion each have. So what we have to do, we are given this number, we have to find their decimal expansion and check whether they are terminating or non-terminating, or if non-terminating of is whether repeating or non-repeating. So first number given to us is, this is answer number 1. First one is 36 by 100. When you find its decimal expansion, as we have 2 zeros in the denominator, so we can write it directly as 0.36. So after 6 there is no digit, so it is a terminating. So I'll write it is terminating. Okay. Second one, we have 1 by 11. When you find a decimal expansion of 1 by 11, you will get 0.09090909 and so on. Or we can write this as 0.09 bar. This bar means that these two digits are in repetition. So here the digits are repeating and non-terminating. So it will be non-terminating recurring. Non-terminating recurring. Third one, Now we have a number 4 is to 1 by 8. First we have to simplify this number by multiplying this number by the number given here. Here we have to do multiplication, then add that product to the number given to here. Okay, so this will be 8 into 4 is 32, 32 plus 1 is 33 divided by 8, and when you find its decimal expansion, that will be 4.125. there will be no digit after 5, so it ends here. So this is simply, it is terminating. Okay, next one, part 4. Which is 3 by 13. The decimal expansion of 3 by 13, when you divide 3 by 13, you will get it as 0.2307669. After this digit will start repeating 2307669 and so on. So we can write this as 0.230769 bar. So it is non-terminating but repeating. So it will write, it is non-terminating recurring. Recurring means repeating. Okay, that's how we have to find whether it is terminating or non-terminating recurring. Okay, first find the decimal expansion and check whether they are terminating or non-terminating. So I have done the first four part of question number 1. The part 5 and part 6 will be your homework. You have to try them by yourself. Okay, like we did the first 4 part. Moving ahead, we have question number 2. It says, you know, that 1 by 7 is equals to 0.142857 bar. Can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? It's very easy. Write it like this. This is question number 2. We are given already the decimal expansion of 1 by 7, so which is equal to 0.142857 bar, and we are asked to calculate the decimal expansion of 2 by 7 without doing the actually division. So we can write this 2 by 7 as 2 into 1 by 7. We are already given the decimal expansion of this number 1 by 7 here. Okay, so we can write this as 2 into, at the place of 1 by 7 we'll write 0.142857 bar. So what we have to do now, multiply this 2 with this number, so you will get it as 0.28 okay, it will be 5714 bar. Okay, when you multiply this by, you will get 0.285714, and then you will put the bar. That will be your answer. Similarly, the value of 3 by 7 will be, we can write 3 by 7 as 3 into 1 by 7. The value of 1 by 7 is already given, which is 3 into 0.142857 bar. So what we have to do is you multiply this 7 by this number. Okay, there is a one short trick to solve this. What you have to do is multiply this 3 here with the first digit here. 3 into 7 is 21. So the unit digit, the digit at the unit place here is 1. So we have 1 here Okay, 1 is here, so its multiplication will be, we'll write the digit after the 1. So this will be like this. 3 into this number will result into 0 point. After 1 we have 4, 2, 8, 5, 7, and then write again 1 bar. Okay, this is a short trick to write this answer. It's only for this case, while for the other number you have to do the actual multiplication. Okay. Similarly, the 4 by 7 can be calculated as 4 can be written as 4 multiplied by 1 by 7 equals to 4 into 1 by 7 is given, which is 0.14287 bar. Again, I'll write its answer by the trick. The 4 into 7 here is 28. So 8 is here. So write digit after 8, which is 0 point. After 8 we have 5, 7. Then start from the first number, which is 1, 4, 2, 8 bar. Okay. So these are the answer of 2 by 7, 3 by 7, and 4 by 7. The remaining two part, which is 5 by 7 and 6 by 7, I think that these two you should try by yourself. So your homework is to try the decimal expansion of 5 by 7 and 6 by 7. So you will try these two by yourself. These two are part of your homework. Okay, it's like we did for these three parts. You can find it for the 5 by 7 and 6 by 7. Moving ahead, we have question number 3, which is express the following in the form of P by Q, where P and Q are integer and Q is not equal to 0. This question is very, very important, because whenever this chapter is included in your syllabus for any test or exam, you will always find one question of this type in your exam. Okay, so understand this one very carefully. This is answer number 3. First one is 0.6 bar. I want to tell this type of question are very important, but also very easy. If you pay attention here, you will understand this easily. So number given to us is 0.6 bar. So always first step is let assume this number is to be equal to x. So write x equals to 0.6 bar. Okay, and name it equation number 1. Okay, the first step is always whatever the given number, you will write that equals to x and name that equation 1. Now the second step is you have to check how many digits are in repetition here. So when you write a decimal expansion of this number, that will be 0.66666 and so on. Okay, that means digit that is in repetition is only number 6. So 6 is repeating after every other 6. Okay, so only one digit here in repetition. So we'll write, since here only one digit is in repetition, so we will multiply 10 on both sides in equation 1. That is, okay, why we are multiplying by 10? Because there is only one digit in repetition. अगर दो digit repeat होती तो multiply करते 100 से. If there are 3 digit in repetition, so we'll multiply by 1000. If there are 4 digit in repetition, then we will multiply it by 10,000. In this case, only one digit is in repetition, so we'll multiply it by 10. So after multiplying by 10, equation number 1 become 10x equals to 6.6 bar. Okay, this decimal will shift to the one place here, so it will become 6.6 bar. Okay, and name it equation number 2. Now the next step will always be on subtracting equation 1 from equation 2, we get Okay, what we have to do is subtract equation 1 from equation 2. That will be, first write the value of equation 2, which is 10x, and on the other side we have 6.6 bar, and from equation 1 we have x here and 0.6 bar. So 10x minus x will give us 9x, and 6.6 bar minus 0.6 bar will result into 6. So x will be equals to 6 by 9, or dividing them by 3 you will get 2 by 3. So the answer is x equals to 2 by 3. That is our answer, which is in the form of p by q. That's what we are asked to find. We have to represent this number in p by q form. Okay, so this 0.6 is equals to 2 by 3. I hope this is clear to you everyone. Okay, let's see the second part. We have 0.4 and then 7 bar. Second part is 0.47 bar. So first step is let x equals to 0.47 bar and name it equation number 1. This is the first step. Always assume that number equals to x. Second step, you have to check how many digits are in repetition. So if you write these numbers, this will be 0.477777 and so on. Only one digit is in repetition again here, which is 7. So write, since here is only one digit is in, since here is only one digit is in repetition, so we will multiply equation 1 by 10 on both sides. On both sides. So we got x into 10 will give us 10x, and 0.47 bar into x will result into, this decimal will shift to one place here, so it will be it will be wait a moment. Okay, so this will be 10x equals to 0.4, not 4, 4 point okay 4.7 bar, and that will be equation number 2. Now on subtracting equation 1 from equation 2, on subtracting equation 1 from equation 2, we get, that is 10x minus x will be equals to 4.7 bar minus 0.47 bar. 10x minus x will result into 9x equals to 4.7 bar minus 0.47 bar will result into 4.3. This is how we got this. We are subtracting 4.777, and here we have 0.4777 and so on. Okay, these all 7 will result into 0, 0, 0, 0 and so on. This 7 minus 4 is 3, Here decimal, 4 minus 0 is 4, so number we got is 4.3, which is written here. So x will be equals to 4.3 by 4.3 by 9, or x will be equals to, when you remove this decimals, you will get 43 by 90, and that's our answer in the form of P by Q. Okay, this is the part second. Now see the third one. We have 0.00 bar, 001 bar. Third one is, I'm just explaining this one, you will complete the third part by yourself. Okay, we have 0.001 bar. Again, let x equals to 0.001 bar. So how many digits here are in repetition? Here are 1, 2, 3 digits on repetition. So we'll multiply by it by 1000 on the both sides. First, name it equation number 1. So write, since here are 3 digits in repetition, so we will multiply equation 1 by 1000 on both sides. Okay, so we got 1000 x equals to 1.001 bar. Okay, this is how this is equals to 0.001001. Okay, and so on. So when you multiply it by 1000, decimal will shift to the 3 places here, so it will be 1.001 bar, which is here. Okay, and that's our equation number 2. So I'm leaving it here. It's your homework to complete this question. You already got 2 equations. Now next step will be to subtract equation 1 from equation 2, and after that you have to find the value of x. So after this you have to complete by yourself. Okay, like we did in this part second and part 1. I have done it till finding the equation number 2. After this you will do it by yourself. Okay, that's part of your homework. Moving ahead, we have question number 4, which is express 0.00000 in the form of P by Q, and are you surprised by your answer? With your teacher and classmate, discuss why the answer makes sense. It is similar like we did in question number 3. Question number 4 is, we have 0.999999 and so on. So let x equals to 0.9 bar. Okay, name it equation number 1. Then you will see how many digits are here in repetition. So we have only one digit which is in repetition. So write, since only one digit is in repetition, so we will multiply ten on both sides in equation number 1, and that is, you will get 10 x equals to 9.9 bar. Why 9.9 bar? When you multiply it by 10, the decimal will shift to this place, so it will be then become 9.9 bar. So that's our equation number 2. So So now on subtracting equation 1 from equation 2, on subtracting equation 1 from equation 2, we get 10x minus x equals to 9.9 bar minus 0.9 bar. 10x minus x will give us 9x, or 9.9 bar minus 0.9 bar will result into 9, or x will be equals to 9 by 9 equals to x will be equals to 1. Okay, so now you can see here x is equals to 0.9 bar, while here we got x equals to 0.1. Are these two numbers similar? Answer is no, definitely these two are not similar. But why we are getting 1 here is, when you write this as 0.9999999 and so on till infinity, that number will approximately equals to 1. So the reason for this one is the 9.999 and so on till infinity is approximately equals to 1. That's where we getting result x equals to 1 here. Okay, I hope you got it. So why it is making sense? Because 0.999 is approximately equals to 1. That's why we are getting answer 1 here. Question number 5 is, what can the maximum number of digit in repeating block of the digit in the decimal expansion of 1 by 17? Perform the division and check your answer. So first we have to find the decimal expansion of 1 by 17, which I have already written here. The decimal expansion of 1 by 17 is this. I have divided this 1 by 17. We got a number like this. After certain steps we got again one remainder here. Since we got 1 here, in the beginning we started with the 1 here. So after this digits will start repeating itself. Okay, after this digit will start to repeat, so we'll stop there. So we'll write this as, this is question number 5. So answer number 5 is 1 by 17 is equals to 0.588235294117647. Okay, and then you put a bar on it, because after that digits will start repeating. So how many digits are repeating here? To count the number of digits, we got 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So there are 15 digits in repeating block. All right, hence there are 15 digits in repeating block. That's the answer of question number 5. Okay, all you have to do is find the division of 1 by 17. Once you got again 1 here as remainder, we will stop there, because after this digit will start to repeat. So there are 15 digits in repeating block. Question number 6. Look at several examples of rational number in the p by q form, with p and q integer and q not equal to 0, with no common factor other than 1, and having a terminating decimal expansion. Those numbers should have a terminating decimal expansion. Let's take some example. I will take 3 examples here. This is answer number 6. Let's take the number which are given in question number 1. The first number given to is question number 1 is 36 by 100. Let's take last one also, which is 329 by 400. Let's take another number, let's say 17 by 32. Okay, so what we have to do is, we are asked to find, can you guess what property q must satisfy? Q means the number in the denominator. Okay, the number in the denominator. So इसकी प्रॉपर्टी फाइंड करनी है हमें. So we'll write the prime factors of the number in denominator, that is of q. This can be written as 36. 100 can be written as in its prime factor 2 into 2 into 5 into 5, or we can write this as 36 2 power 2 multiplied by 5 power 2. We can write this next one as 329 divided by 400 can be written as in its prime factor 2 into 2 into 2 into 2 into 5 into 5. So this will be 329 2 power 4 and 5 power 2. And the last one is 17 by 32. 32 is 2 into 2 is 4 into 2 is 8 into 2 is 16 into 2 is 32. So here we got 17 divided by 2 power 5. Now you can observe that the q is in the form of either power of 2 here, power of 5, power of 2, power of 5 and power of 2. So you will find that the prime factor of q is in the form of 2 power m multiplied by 2 power n. Okay, that is either the power of 2 or power of 5 or both. You can also write this one as in the form of 2 power m into 5 power n with 5 power 0. 5 power 0 is 1, 1 into this number is again the same number. So this is the answer of question number 6. Okay, the conclusion from here is the q is in the prime factor of q is in the form of this formula when the number have a terminating decimal expansion. Okay, next question, which is a very simple question. You have to write 3 number whose decimal expansion are non-terminating and non-recurring. You can choose any 3 number. The decimal number should be non-terminating and non-recurring. Let's write a number 0 0.1 2 3 4 5 6 7 8 9 and so on. It's like 10 11 12 13 and so on. You can choose another number like 0.01 001 0001 00001 and so on. Another number can be 01 011 0111 01111 01111 and so on. You can write as many as number you want to write. There are infinite such numbers. Okay, it should be on, if it is a, it should be non-terminating and non-recurring. Terminate भी नहीं होना चाहिए और digit repeat भी नहीं होना चाहिए. Okay, next one is find 3 irrational number between 5 by 7 and 9 by 7. Okay, we are given 2 number, you have to find 3 irrational number between these 2 number. So I have find the decimal expansion of these 2 number. This is 5 by 7 and this one is 9 by 7. Okay, 5 by 7 and 9 by 7. So their decimal expansion result into 5 by 7 is equals to 0.71428 and so on, while 9 by 11 result in 0.818181 and so on. So you have to write 3 different rational number between these two, 3 different irrational number between these 2 number. So you can write any number which lie between these 2 number. So one can be 0.71 because we have 7 and 1. After this we write next digit is 4, right? Any number greater than 4, right? Let's write it 716. Then 01 001 0001 00001 and so on. Other one can be 0.72. Then again write 601 001 0001 00001 and so on. Another can be 0. We have 81, so write a number less than this 806. 0 1 0 0 1 0 0 0 1 0 0 0 0 1 and so on. Okay, you can write as many as number you want to write between these two given numbers because there are infinite such number. Okay, next one is classify the numbers as rational number or irrational number. The first one here is root 23. As we know, 23 is a prime number, so root of any prime number is irrational number, so we'll write irrational. Second is root 225. Not all root number are irrational because 225, the square root of 225 is equals to 15, which is a rational number. Next one is 0.3796. So its decimal expansion is ending at 6, so it is again a rational number. Next one is 7.478478 and so on. So we can write this one as 7.478 bar. It is non-terminating but recurring. So non-terminating and recurring number are also rational number. Next one, fifth, 1.101 001 0001 00001 and so on. So this number is a non-terminating and non-repeating, so it's a irrational number. Right number here also. So that's the end of exercise 1.3. We have covered all the question in this video. Okay, so this is your homework. You have to try question number 1, part 5 and part 6. Part 3, you have to complete question number 2, and you will also try the example 6, 7, 8, 9 and 10. That's your homework. Okay, watch this video carefully, understand all the question which are very important. Even after this you face any doubt or difficulty, you can ask that in the comment section of this video, or you can send me a